Hi everyone, and welcome to The Sleepy Scientist. I'm really happy you're here. Tonight, we're going to go on a calm and quiet trip to learn something amazing. So get comfy, take a deep breath, and let's enjoy this peaceful science story together. Before we start, tell me in the comments, where are you watching from and what time is it for you right now? If you like relaxing science videos, don't forget to tap the like button. Now let's begin. In the heart of almost every galaxy, there lives something vast and silent. It does not glow, does not speak, and does not move like other things in space. But it waits, it rests, it holds everything close like a calm parent holding the arms of a spinning child. This is a black hole, not the terrifying monster of wild stories, but a quiet giant, so gentle in its stillness, so powerful in its sleep. Galaxies are not wild by accident. They spin in elegant spirals, some tight like a seashell, others loose like a dancer's arms. In the middle of these galaxies, something invisible keeps the dance in rhythm. We do not see it with our eyes, but with instruments that feel the gravity it leaves behind. At the centre, we find what scientists call a supermassive black hole. Not the kind made from a star's last breath, but something older, larger, 1,000,000 or even 1,000,000,000 times heavier than our Sun. And yet it does not roar, it does not chase, it simply exists. Imagine a still lake with a stone resting on its floor. The water ripples around it, but the stone is unmoved. That is how galaxies swirl around black holes. It is not the black hole that spins, but the stars and dust and gas that feel its quiet pull. Some stars move faster near the centre, tugged by this sleeping presence. Others drift farther, still feeling its touch even across light years. Long ago, before stars filled the sky, black holes may have helped shape the galaxies themselves. Some scientists believe these giants were born very early, even before many stars had time to shine. As clouds of gas came together, pulled by their own weight, black holes formed like seeds in the centre of a blooming flower. And from these seeds, galaxies grew, wide and wild, but always circling something deeply calm. We often imagine black holes as things that destroy, but many of them spend most of their time not doing much at all. They are like deep wells in space. Only when something comes too close, perhaps a wandering star or a trail of gas, do they wake just a little. Then they stretch their gravity like fingers and gently pull the object in, not with noise or violence, but with a slow, invisible tug. The object falls, circling, first like a leaf on water, then faster, tighter, until finally it disappears. But for millions of years these giants can sleep. They are not always eating, they are not always glowing. In fact, the quietest ones are often the most peaceful, resting in the middle of galaxies, shaping the paths of stars without saying a word. If you could float in space and look at one, you would not see it. You would see stars racing around something that isn't there. You would feel its presence in what does not move, a stillness that holds the galaxy together. And isn't that something beautiful? That the most powerful thing in a galaxy is also the quietest, that something can be strong without shouting, that the calmest hearts can hold the biggest storms. So next time you look at a picture of a galaxy, think of the middle, think of the place where nothing shines but everything turns. There lies a sleeping giant, at peace in its silence, watching the stars swirl like dreams around a centre that never moves. Let's drift deeper into that still centre where silence has weight. Black holes do not just sit at the core of galaxies, they shape time itself. Imagine a river flowing gently. Now place a heavy stone in that river. Around the stone the water bends and swirls. In space, time is like that river, and a black hole is the stone. The heavier the black hole, the more space and time curve around it. If you were to fall toward a black hole, every moment would stretch. A single second could feel like a lifetime, depending on where you stand. Scientists call this gravity's warping of time. It is not just a thought, but something we can measure. Satellites around Earth already tick more slowly than clocks on the ground, just a tiny bit. Around a black hole, this effect becomes extreme. Light itself bends and slows. Signals stretch. Time drips slowly like honey from a spoon. Even though we cannot touch black holes, they let us see the edge of time. Around each one is a line called the event horizon. It is not a wall. You would not feel it if you crossed it, but it marks the last moment where escape is possible. Once you pass it, not even light can come back. This makes black holes invisible, but not unknowable. We see what they do to stars around them. We see gas spiral in and light up like a last candle before darkness. We see flickers, waves, echoes, soft whispers in radio waves and X-rays, telling us something massive and silent is close. It is the contrast that is beautiful. Around the black hole, matter becomes wild. Gas and dust swirl in great storms. Temperatures rise to millions of degrees. Light bursts out in jets, shooting far into space like fireflies escaping the dark. But the center, still silent, no light, no heat, only gravity, perfect and pure. And yet, these sleeping giants are not alone. Many galaxies have not one but two black holes, slowly dancing toward each other. When galaxies merge, their black holes meet like old stars falling in love. They do not collide right away. For millions of years, they circle one another, drawing closer inch by inch. When they finally touch, they shake the fabric of space itself. These are called gravitational waves, ripples in space-time like rings spreading in a pond after a stone falls. We can now detect those waves, soft and distant, like feeling the heartbeat of the universe. It is strange to think something we cannot see can make waves we can feel across the cosmos. But that is the nature of black holes. They do not need to be loud to be noticed. They do not need to shine to be powerful. Their pull is enough. Their punto is full. In recent years, we've captured the shadow of a black hole, like photographing a whisper. Using telescopes across Earth, linked together into one giant eye, scientists stared at the center of a galaxy called M87. There, they saw not the black hole itself, but the light around it, bent and twisted into a glowing ring. It was not sharp, it was not perfect, but it was real. And in that fuzzy image, the world saw something ancient and calm resting at the center of storms. Some call black holes cosmic prisons, others call them engines of galaxies, but they are also teachers. They remind us that power does not always need form, that something can be invisible and still matter, that stillness can shape the dance of stars, that silence can echo across space and time. When we look up at night and see the Milky Way stretch like a ribbon of light, we are seeing the outer arms of our own galaxy. But at the center, hidden behind clouds of dust and gas, it's a black hole called Sagittarius A. It is not eating much right now, it is not glowing brightly, but it is there, holding the galaxy gently in its curve. We are so far from it, more than 20,000 light-years away, but it shapes us still. It shaped where the stars formed. It shaped the spin of the galaxy. It shapes the space we drift through now, quietly always. And so we return to the thought that black holes are not only endings, they are not just places where things vanish, they are also beginnings. They mark the center of things. They teach us about gravity, time, and light. They help us understand the universe not by their noise, but by their grace. In their stillness, they offer us a new kind of wonder. Not the flash of a comet, not the explosion of a supernova, but something deeper. A presence, a pause, a gravity that holds the story together. Now imagine yourself drifting near the center of a galaxy. There is no sound here, only the deep quiet of space like the hush before dawn. Stars shimmer far away. Dust clouds move slowly, like ancient breath. And in the center, invisible but steady, rests a black hole. It does not ask for attention. It simply holds, not with hands, not with force, but with the gentle power of gravity. This is the final part of the story, a place of endings, yes, but also of deep understanding. Black holes are not alone in their silence. All through the universe there are things we do not see, yet they shape what we know. Gravity, magnetism, time itself, these forces move without faces. But black holes give these invisible forces a shape. They show us what gravity can become when it has no limit. When matter folds in on itself, not with anger, but with weight, with certainty, with finality. Scientists have wondered what lies inside a black hole. Not just past the event horizon, but deep within, where space no longer stretches and time no longer moves. The equations break there. Our knowledge ends at the edge. Some call it a singularity, a point of infinite density, but no one can see it. No one can measure. It is like a secret the universe keeps safe, wrapped in silence. Perhaps one day we will know more, perhaps not. But there is peace in not knowing everything. There is beauty in mystery, especially when it moves the stars. There are other kinds of black holes too. Some are small, born from the final sigh of a dying star. They do not spin galaxies, they do not weigh 1 billion suns, but they still hold space around them in quiet hands. When two of these small black holes meet, they spin and spiral and merge. In that final moment, the energy they release shakes space itself. These tiny giants, less than a city in size, can ripple the very fabric of the cosmos. And yet, for most of their lives, they are still, waiting, resting, dreaming of gravity. In a way, black holes are a mirror. They show us the limits of what we can understand. They show us that not everything bright is powerful and not everything dark is empty. They remind us that some things exist quietly, shaping the world without a sound. A teacher does not always shout. A heart does not always race. And the most important things, the ones that hold galaxies together, may live in silence. In recent times, poets and scientists have both tried to describe black holes. One uses numbers, the other uses metaphors, but both try to describe what it feels like to imagine something so big, yet so calm. Something that bends time and holds light, yet remains unseen. Something that is an end, and yet not the end of understanding. And this too is part of the story, that black holes may one day fade. Not through explosion or collapse, but through a slow, endless leaking. A whisper of particles, a shimmer of heat, Hawking radiation as it's called. A black hole over a time longer than the age of the universe may simply vanish. No light, no noise, just gone. A silent goodbye, written not in stars but in empty space. Until then they remain, at the centre of galaxies, in the places where stars once burned, in the parts of the sky where nothing shines but everything turns. Sleeping giants, peaceful anchors, timeless watchers of the cosmic sea. As we close this story, we leave the centre of the galaxy. We drift outward, past stars and dust, past light and memory. But something remains behind, a presence, a pull, a stillness that does not fade. The black hole does not move, it does not speak, but it is there, and in its silence the galaxy spins. In its gravity the stars remember where to go, in its shadow the story continues. The universe is vast, and much of it is loud. Supernovas, solar flares, crashing worlds. But sometimes the greatest power lies in stillness, in patience, in a force that does not shout but simply holds. And maybe, just maybe, the black hole is not asleep at all. Maybe it is awake in a way we cannot understand, watching, holding, dreaming with gravity. A sleeping giant not because it does not care, but because it understands everything so well, it does not need to move. And that is how the centre of a galaxy breathes, not with sound or light, but with the calm strength of something that knows its place in the stars. In the quiet fabric of the universe, time is not always the same. It moves like a river, sometimes fast, sometimes slow, depending on what it flows around. And near a black hole, time does not simply pass. It bends, it lingers, it stretches out like a long breath, held just a little too long. If you could stand safely on the edge of a black hole and look out, the stars would seem to move quickly. Their light would dance faster than usual. But if someone looked at you from far away, they would see you moving slowly, like a dream, played back in slow motion. Time here is not broken. It is just listening. It is waiting. It is being pulled. Black holes are the deepest wells in space. They bend more than just light. They bend the very structure of reality. Space and time are woven together like threads in a fabric, and black holes pull those threads tighter at the centre. This stretch is not sharp or sudden. It is soft, like pulling taffy, slow and strong. The closer you get to the black hole, the more time changes. A clock near the edge ticks slower than one far away, but to the clock itself nothing feels different. It just runs, quietly, calmly, unaware of the shift. This is one of the strangest truths in the universe, that time is not fixed, it can be shaped. And black holes shape it more than anything else. They do not need to try. Their mass alone is enough. Like a mountain pressing into the earth, their weight curves the ground beneath them. But instead of soil and stone, it is time itself that bends. Deep down near the event horizon, the line where nothing escapes, time nearly stops. Not for the black hole, it does not experience time the way we do, but for anything falling in, that last stretch of space is endless. From the outside it seems to freeze. A falling star appears stuck forever at the edge, caught in a moment that never ends. But inside the star keeps moving, it continues to fall, it crosses the line and vanishes silently, into a future no one else can see. This is what some call a one-way door, a path through time that leads only forward, never back. We do not know what happens beyond the edge. Equations give us guesses, but nothing certain. The black hole keeps its secrets, hidden in the folds of curved time, and still, it listens. It listens through gravity. It listens through light that almost escapes but cannot. It listens through the swirl of gas and stars that pass close, bend in their path and whisper their presence in soft beams of X-rays and gravitational waves. These are the echoes of time's slow song playing gently around a silent, steady listener. There is beauty in this listening. It is not passive. It shapes everything. Black holes do not chase time. They hold it. They mold it. They show us that time is not just something we measure with watches or calendars. It is something that can feel weight, something that can stretch when pulled, something that listens when mass gathers in silence. In the universe, there are clocks made of stars, of atoms, of light. But near a black hole, all those clocks fall out of rhythm. And yet the black hole itself is a kind of clock. It tells time differently. It counts not in seconds, but in changes, in the bending of light, in the curving of space, in the slowing of everything near it. Its time is deep time, time that moves in spirals, not straight lines, time that remembers everything, even if it never tells. So when you think of a black hole, do not picture only darkness. Picture stillness. Picture a place where time itself stops to breathe, where moments linger longer than they should, where the universe slows as if pausing to remember. This is how black holes listen, not with ears, not with eyes, but with gravity and silence and the soft reshaping of time's quiet flow. Let's drift closer to the idea of time, not as something we lose, but something we live inside. In everyday life, time feels steady. A second is a second, no matter where we are. But in the universe, this is not true. A second can stretch, a minute can bend. Time listens to gravity, and nowhere is gravity more powerful than near a black hole. This gentle truth changes everything we know about how the universe moves. If you set two clocks, one on Earth, and one near the edge of a black hole, the one near the black hole will tick more slowly, but it won't feel slower. The person beside it will live each moment as usual, unaware of any difference. It's only when compared to the clock on Earth that the difference appears. This is called time dilation. It's not a trick, it's not science fiction, it's real. And it shows that time is not a simple path, it's a curved, moving landscape. This effect happens all the time, even here. GPS satellites orbiting Earth experience a tiny bit of time dilation. If we didn't adjust their clocks, your phone would get lost by miles. But near a black hole, this effect becomes stronger. It becomes something you can feel. Imagine spending just a few hours near a black hole and returning to find that hundreds of years have passed outside. That's how powerful the pull of gravity is on time, and it goes even deeper. As you approach the event horizon, the boundary where escape becomes impossible, time slows more and more. To an outside observer, you seem to freeze just before crossing. But from your view, you keep moving, smoothly, gently falling inward. Past the horizon, no signals can escape, no messages, no light. Not because they are broken, but because space itself is falling faster than light can travel. It's like trying to swim upstream in a river that moves faster than anything can swim. Inside, time may behave in strange ways. Some theories suggest it could end at a point called a singularity. Others imagine tunnels to distant places, bridges through space and time. These are not proven, only dreamed. But even the dreams are shaped by gravity and time, by the deep rules that black holes obey without question. We may never know what happens inside, but we can learn everything from the outside, from how the black hole affects the world around it. And it does more than hold time, it changes the rhythm of space itself. Stars that pass too close are stretched thin, like ribbons of light. Gas swirls into glowing spirals heated by the speed of its fall. These signs, bright, flickering, trembling, are how we know something powerful is there. We don't see the black hole, we see its silence lit up by those who come near. When two black holes circle each other, time warps even more. Their spiral tightens, space around them curves and dances, and when they finally merge they send out a wave, not of light, but of time itself, These waves, called gravitational waves, ripple across space. They pass through galaxies, they pass through planets, they pass through us. Not loud, not dangerous, just a whisper in the shape of time. We have built tools to listen to those whispers, giant instruments called LIGO and Virgo. They stretch arms kilometers long and wait for tiny movements, smaller than the width of an atom. And yet, they hear the dance of black holes billions of light years away. They hear the rhythm of deep time, the music of merging gravity. Each wave tells a story of two black holes, alone in space finding each other, circling, spiraling, finally becoming one. And when they do, space stretches, time wobbles, and somewhere far away a wave reaches us, a final note from a long-forgotten dance. There is poetry in this, though it is written in physics. It says that black holes do not only listen to time, they create it. They change its pace, they mould it like clay. They teach us that time is not just a path we follow. It is a living part of the universe, shaped by weight, by silence, by gravity. The closer we look, the more we understand that time is not separate from space, it is part of a fabric. And when that fabric curves, time curves too. Black holes are not just holes. They are wells, they are songs, they are clocks whose hands move differently for each of us. And in this curved time, new questions rise. What does it mean to age? What does it mean to wait? Could someone near a black hole ever return to a world that has aged without them? These are not just science questions. They are human ones. They touch our hearts because they touch our place in the universe. So let's sit with this thought a little longer. That time near a black hole becomes something soft, something stretched, something thoughtful. It is not broken, it is just listening to mass, to dance to the calm pull of gravity. And in its listening, it tells a deeper story of the universe's quiet, powerful shape. Let's return now to the idea of a black hole, not as a danger, but as a place where time slows to a whisper, where motion softens and gravity becomes a song played on the strings of the universe. A black hole does not just bend the space around it. It bends the story of time itself. And in this bending it holds a message, that time is not rigid, not fixed, not the same for all who move within it. There is something peaceful about this truth, that time is shaped by experience, that a clock in one place may tick differently than a clock in another. Near a black hole, this idea becomes more than theory. It becomes real. It becomes a rhythm of light and gravity and silence. And in that rhythm we learn not only about the stars, but about ourselves. Imagine an astronaut drifting near the edge of a black hole, not too close, just near enough to feel the slow pull of time. To them, the universe outside would race. Stars would burn and fade in the blink of an eye. Planets would spin through centuries while their own heartbeat stayed slow and steady. And when they finally turned back, if they could, they would find a world aged without them. A world they remember, now changed. It is a lonely idea, but also a poetic one. That time can carry us not just forward, but away from the familiar. That gravity can draw not just mass, but moments. This strange nature of time near black holes has inspired more than science. It has sparked stories, dreams, questions too wide for answers. What if black holes could let us see the future? What if they held the past inside? Could someone fall through a black hole and emerge elsewhere, else when? These are ideas that reach beyond what we can test, but they come from a place of curiosity, the same place where science begins. And still, the black hole remains quiet. It does not answer, it does not change. It simply waits, holding its shape in the fabric of space. All around it, time dances, but within, time may end, or change, or slip into something else entirely. Some say there is a core, a singularity, where time and space become one. Others believe the singularity is only a sign that we don't yet understand everything, that the rules of physics break down, not because they are wrong, but because they are incomplete. This is the beauty of science, that even the unknown has meaning, that even silence can be studied. Every orbit, every ripple, every shadow of light bent near a black hole tells us more, not through noise but through stillness, not through explosions but through gentle warps in reality. And every time we listen, we learn a little more about how the universe speaks. Now we know that black holes are not rare. They fill galaxies like quiet hearts, some large, some small. Each one changes the pace of time around it. Each one holds stories we may never hear, and yet by watching how time bends near them, by listening to the changes in light and wave, we begin to read their stories, written not in words but in time itself. Some scientists believe that time near a black hole may give clues to the origin of the universe, that the extreme bending of reality might reflect what happened at the beginning when everything was compressed into something small, hot and dense. Perhaps studying the end helps us understand the start. Perhaps the deepest gravity is also the deepest memory. In the end, black holes show us that time is not a machine. It is not a ruler. It is a river. It moves with the shape of space, with the presence of mass. And like any river, it flows differently through valleys and hills, through still pools and crashing falls. Black holes are the deep pools where time slows to a stop, where reflection is possible, where silence holds meaning. So when we think about the lives of black holes, we should also think about the life of time, about how it can stretch and bend and twist, about how our understanding of it has changed. From sun shadows on ancient stones to ticking atoms in modern labs, we have chased time like a butterfly, always just ahead of our grasp. And yet, near a black hole, we come closest to holding it. The story of black holes listening to time is not only a story of physics, it is a story of patience, of humility, a reminder that not all things move at the same pace, that the universe has places where the moment lingers, where the next second waits, where gravity listens so deeply it holds time in place. And perhaps in our own lives we can learn from this, to slow down, to feel the shape of time around us, to notice that not all the moments must rush forward. Some moments, like the space near a black hole, are meant to stretch, to hold us gently, to remind us that even in silence, even in stillness, there is something sacred unfolding. This is how black holes listen to time, not by moving fast, not by changing loud, but by being so deeply still that even time pauses to sit with them. And in that pause, something extraordinary is revealed. Gravity is one of the quietest forces in the universe, and yet it never stops working. It does not flash like lightning. It does not crackle like electricity. It does not roar like fire, but it is always there, pulling, shaping, folding space and time into soft curves. We feel it when we drop a stone, when we leap and return to the ground, when the moon pulls the tides. But far beyond Earth, in the deep stillness of space, gravity becomes something more, something that shapes the structure of galaxies, something that holds the stars in long spirals, something that dreams in silence. Black holes are gravity's most quiet and powerful creation. They do not glow, they do not move with haste, but their gravity is strong enough to trap even light. It is not violence that creates them, it is collapse. A star that has burned through all its fuel begins to fall in on itself layer by layer, until nothing can stop the inward pull. No pressure, no force, no scream of heat. Just a slow, silent folding. And then the star becomes invisible. Its light, its shape, its voice all gone. Only its gravity remains, stronger than ever, holding more tightly than ever, but never loud. In this way, gravity becomes the shape of memory. It remembers where the star once lived. It holds its place in the sky even when the star has vanished. Other stars still feel the tug. Light still curves as it passes by. Space still bends. Gravity does not forget. It dreams of the star that once was, and in dreaming it reshapes the universe around it. This dream is not sharp. It is not fast. It unfolds slowly, like a ripple in a frozen lake. Imagine a place where everything moves according to gravity's rules, where orbits are long and slow, where dust collects in quiet spirals, where entire galaxies swirl in patterns they cannot feel, but cannot escape. That place is all of space. From the tiniest rock to the largest black hole, everything is part of gravity's soft, steady design. Even light cannot ignore it. When a beam of light passes near a black hole, it bends, not because it wants to, but because space itself has curved, and light, which always travels straight, must now follow the curve. It is like a marble rolling along a warped surface. The path has changed, so the traveller must change too. This is how black holes show their presence, not by shining, but by bending what shines near them, not by speaking, but by changing how others move. And what about the space near a black hole? is not just bent, it is deep. Time slows down, orbits grow faster, energy grows higher, but the black hole itself remains still, like a stone in the middle of a turning wheel. It does not need to chase, it does not need to call. Its gravity speaks in forms, and everything listens. This is why we say gravity dreams, because it shapes without sound, because it moves stars into patterns like poems written in light, because it teaches without effort. Black holes are the clearest expression of this dream. They are gravity's softest whisper made real, and even though we cannot see inside, we can feel their pull from across the stars. The centre of our own galaxy holds one of these dreaming giants. It has been there since long before our sun was born. It did not ask to be seen, it did not rush to grow, it simply waited, its gravity gathering slowly, folding space and time like a blanket drawn over the heart of the Milky Way. And now, every star in our galaxy dances around it, not out of fear, but because gravity has made the space around it into a slow, endless song. That is the beauty of silent forces. They do not need to shine to be strong, they do not need to move to change everything. They hold the universe not by force but by presence. They exist in the background, letting others take the stage while shaping every scene from behind the curtain. So let us remember that gravity is not just what pulls us down. It is what holds the Earth in orbit, what lifts the tides, what keeps the moon near. And in black holes, it becomes something even deeper, something that holds light, that bends time, that shapes galaxies without ever making a sound. This is the gravity that dreams in silence. A dream so large that the stars swirl in its sleep. A dream so quiet that the universe leans in to listen. Let's follow this silent gravity a little deeper, into the spaces between stars where light dims and time slows. Here, in the calmest parts of the universe, gravity is not a force of war or struggle. It is a presence, soft and unspoken, that shapes everything without needing to be seen. Black holes are the purest form of this presence. They are not made of matter in the way we know it. They are made of space curved so tightly that it folds in on itself. And in that fold the dream continues, slow, quiet, and endless. Think of a black hole not as an object, but as a place where gravity has become so strong that nothing can resist it, not even time. Around it, stars move faster, gas heats up and glows, particles twist in paths like ribbons caught in water. But the black hole itself does not spin in the same way. It is not rushing or burning. It is simply there, like a deep breath held in the middle of the galaxy. As this breath grows, when gas or dust falls toward the black hole, it spirals inward, forming a disk of glowing light. But even this light cannot last. It vanishes at the event horizon, the edge of no return. We call it a horizon not because it is distant, but because it is a limit. Beyond it we cannot see, beyond it we cannot return. And yet, what falls does not fall in vain. Its light tells us a story. Its heat reveals the edge. Its motion draws a map of the invisible. This is how we know black holes are there. We see the matter that circles them. We see the patterns that cannot be explained by anything else. We listen to the space around them and hear the hum of something massive, something still. It is like hearing the shape of a mountain by listening to the wind that flows around it. The mountain does not move, the wind tells us it exists. Sometimes black holes collide. These are not quick events. Two black holes may orbit each other for millions of years before finally merging. And when they do, their masses combine, their horizons stretch, their silence deepens. But in that final moment they send out waves, gravitational waves that ripple across the universe like a heartbeat echoing through space. These waves travel without light, without sound. But we can feel them. Instruments on Earth, quiet and precise, can detect the stretch and squeeze of space caused by these waves. It is as if gravity has spoken for just a moment, and the universe has listened. And yet, even in collision, black holes do not become loud. They do not explode, they do not scatter. They merge with grace, with stillness, with gravity's slow dream continuing in a new shape. The new black hole is heavier, larger, and quieter still. It holds the memory of both. Their spin, their mass, their paths are now one, and space bends just a little more around this new centre of silence. But black holes do not need drama to be beautiful. Most live alone, most do not feed. They rest in the center of galaxies, untouched for millions of years. Their gravity shapes the motion of stars. Their presence keeps galaxies from drifting apart. Without them, the spiral arms might unwind. The orbits might loosen. The balance might break. Black holes hold this balance. They do not control, they do not force. They simply remain, and in remaining they guide. This is why we say gravity dreams. Because it shapes without asking, because it holds without grasping, because it makes the universe possible without ever demanding attention. Black holes are the deepest part of this dream. They are the point where gravity no longer needs a voice. Where the rules of space and time bend around an idea so powerful it does not need to be seen. Scientists once believed black holes were impossible, that something so dense, so curved could not exist. But now we know they are real. And not just real, but common. Not just heavy, but peaceful, not just strange, but essential. The universe makes black holes the way trees make roots, quietly, patiently, with a deep purpose. So as we move through this story, let us carry this image. Gravity, resting in the heart of a galaxy, dreaming in curves. Each star a note, each orbit a line, each silence a truth. There is no need to hurry in this dream, no need to shine, only to remain, only to hold, only to shape the world by being deeply still. The dream continues, always, in the space between stars, in the curve of planets, in the pull of the earth beneath your feet. And at the very center of everything a quiet force sleeps, shaping galaxies in silence. Now let's drift toward the final part of gravity's dream, a place beyond motion, beyond light, where silence becomes deep enough to hold the shape of everything around it. A black hole does not chase or fight. It waits, and in that waiting it draws stars near. It shapes galaxies not with speed, but with stillness, not by force but by presence. This is the last and softest lesson of gravity, that sometimes the greatest power lies in not moving at all. Inside the black hole, beyond the event horizon, our understanding begins to fade. Equations tremble, time loses its shape, space folds inward on itself. At the core may lie a singularity, a place so dense, so small, so curved, that no law we know can describe it. But perhaps that is not the point. Perhaps the purpose of the black hole is not to show us what is inside, but to teach us how the universe responds when gravity dreams without limit. Even if we cannot see the center, we can see what it does. We see stars orbiting something invisible. We see gas spinning into glowing disks. We see light stretched, twisted, and pulled. We hear gravitational waves, soft, silent ripples sent across space. We observe, we measure, we wonder. But the black hole does not need to reveal itself to be understood. Its effect is enough. Its silence is loud enough to echo through time. And yet even black holes are not forever. Some scientists believe they may one day fade. A theory called Hawking radiation suggests that black holes slowly leak energy. Not in big bursts, but in tiny, gentle whispers. Particle by particle they lose mass, like a candle burning in slow motion. Over billions upon billions of years, a black hole may shrink, dim, and vanish, not with an explosion, but with a sigh too quiet to hear. The last thing left would be a ripple in space, a soft memory of where gravity once dreamed. But that day is far beyond us. For now, black holes remain. They live at the hearts of galaxies. They wait in the shadows of space. They hold time in their curve. They listen without needing sound. They dream without needing sleep. And in doing so, they remind us that not all change is loud, that not all beauty shines, that not all force is fast. Think of the pull of Earth beneath your feet. It is gravity. It is gentle. It holds oceans in place. It keeps the moon in orbit. It cradles you as you stand. Now imagine that same pull grown beyond measure, curled into itself, quiet and complete. That is a black hole. That is the final shape of gravity's long, slow dream. We often think of space as cold and empty, but in truth it is full of shape, full of rhythm, full of motion that follows silent patterns. Planets orbit stars. Stars orbit galactic centers. Galaxies themselves drift in clusters. And at the center of many of these systems, still, patient, and nearly invisible, is a black hole drawing everything together in a quiet embrace. Perhaps that is why we feel so drawn to them, not just as objects of science, but as symbols of something deeper, of stillness, of mystery, of the power of silence to shape a universe. In a world that often rushes, where noise and light and motion fill every corner, the black hole offers something else, a pause, a presence, a reminder that calm can be powerful, that silence can hold a galaxy in place. So let us leave this story with that thought resting softly in our minds. That gravity, the force that built the stars and cradles every step we take, also dreams. And in its deepest dream, in its most peaceful form, it becomes a black hole, not to erase but to shape, not to end but to hold, a perfect quiet center in a universe that is always spinning. And somewhere far across the stars, in a place where time slows and light bends, one of these dreaming giants still waits. It does not speak, it does not shine, but it holds the galaxy gently like a thought too big for words. And in that silence the dream continues. Light travels fast, faster than anything else we know. It moves through space at a speed that lets it cross the distance from the sun to Earth in just 8 minutes. It glows from stars that are billions of years old and still reaches us, twinkling across the night sky. Light carries stories, memories, heat, and hope. It paints the universe with colour and shape, but even light, for all its speed and grace, cannot escape everything. There are places where light comes close and never returns. These places are black holes. To understand why light cannot escape, we must think about how space behaves near a black hole. It bends, not like a soft curve on a road, but like a funnel that grows steeper the closer you get to its centre. A black hole curves space so much that, at a certain point, even the straightest path loops back inward. Light, which always travels straight through space, finds that its path is no longer free. The shape of space itself turns inward, and light, following the rules of nature, turns with it. There is a boundary where this begins. It is called the event horizon. It is not a wall or a surface. It has no edges or cracks. It is simply a point in space where the rules change. Before the horizon, light can still escape if it tries hard enough. Past it, light has no choice. It spirals inward, deeper and deeper, until it disappears from our view forever. Not because it has stopped existing, but because it can no longer reach us. We say that black holes trap light, but this is not quite right. The black hole does not grab or tear. It does not burn or break. It simply bends space and time so gently and so completely that escape becomes impossible. Light falls not because it is weak, but because space has turned into a trap that no speed can beat. And yet this falling light tells us much. As it nears the event horizon, it stretches, its colour shifts. What was once blue becomes red, then darker, until it fades into blackness. This is called gravitational redshift, a soft change in the song of light as it struggles to rise against the pull of the black hole. It is the final whisper of something trying to remain visible, and though we cannot hear it with our ears, our telescopes can see it measuring the slow, sorrowful stretch of light's last message. Around some black holes, before light falls in, it dances. Gas and dust that orbit the black hole heat up, glowing brightly. The light they release circles the event horizon like a ring of fire, sometimes completing several loops before flying away. This glowing ring, this soft curved mirror of light, is the last farewell of everything that almost fell in. It paints the edge of the invisible. This is what we saw when scientists photographed a black hole for the first time. Using telescopes across Earth, they captured the ring of light around a black hole in a galaxy far away. It was not perfect, it was not bright, but it was enough. Enough to prove that light, when it comes too close, does not escape. Enough to prove that black holes are not just theories, they are real places, with edges made of time and light. Still, the idea that light can be trapped feels strange. We trust light to guide us. It reflects from every object we see. It travels from the stars and touches our skin as warmth. But near a black hole, even light must bow to gravity. It cannot move freely. It cannot go where it pleases. It follows the curve and then it vanishes. And yet, what is lost to one place becomes a mystery to another. The light that disappears into a black hole is not destroyed. It is simply out of reach. Some wonder if it still exists inside, swirling forever. Others think it may be transformed into something new. There are theories, questions, dreams, but what remains clear is this. When light comes close to a black hole, It meets a horizon not just of space but of knowledge, a place where our understanding falters and our curiosity deepens. So let us not think of black holes as darkness alone. Let us think of them as thresholds, where light reaches the limit of what it can do and still tries to shine, where photons run their longest race and leave behind the softest trails, where silence begins not in fear but in wonder. In the end, when light comes close and does not return, it leaves behind a trace, a bend, a shadow, a glow. These are the signs we follow. These are the marks of the boundary between what we know and what we still hope to see. Let's move now into the quiet space around the black hole's edge, where light begins to falter. Here the world is still visible, but it is changing. Photons, those tiny weightless messengers of light, circle and sway. They speed forward, trying to escape, but the path beneath them shifts. Space is curved, and the closer they drift to the event horizon, the more curved it becomes. Time itself begins to stretch, and light, though weightless, begins to feel heavy. It grows redder, slower, dimmer, until eventually it no longer escapes. This is not a sudden change. There is no scream, no flash, no final spark. It happens gently. A photon near the edge might travel for years, looping around the black hole again and again, drawn closer with each lap. It does not know what awaits it. It only follows the shape of space. And when it crosses the horizon, it keeps going, not because it wants to fall, but because there is no longer a direction to rise. This behavior, this strange surrender of light, is what defines a black hole. Not its darkness, not its mystery, but its quiet command over even the fastest thing in the universe. Light has no mass, yet it must obey. It cannot break free because freedom requires space to move, and space near a black hole points inward. Always inward. The horizon is not a wall, it is a flow. A place where all directions lead to one fate. Outside this edge, light still plays. It reflects from the glowing rings of gas and dust. It scatters into the universe, carrying the story of what almost fell in. These regions can shine brighter than 1 trillion suns. They are called accretion disks, vast whirlpools of matter circling the black hole's boundary. The friction and heat within them causes particles to crash and spin, releasing energy that blazes across space. Sometimes powerful jets shoot from the poles of these disks, narrow beams of particles and radiation, launched by the magnetic forces from the black hole's spinning motion. Even though the light within the horizon is lost to us, the light just before it is our teacher. It shows us where gravity bends the hardest. It draws maps of the invisible. It creates echoes of this black hole's spin and mass. And it shows us how black holes grow, slowly, steadily, not by chasing matter, but by letting time do the work. When stars drift too close, when gas clouds fall inward, the black hole does not lunge. It waits. Its gravity does the pulling, its summness does the shaping, and still light dances. Even photons that do not fall still feel the pull. They bend. Their paths curve around the black hole in arcs we can trace. This bending is called gravitational lensing. It makes galaxies behind a black hole appear stretched, curved, or even mirrored. We use this lensing to find black holes too quiet to glow. We measure the shape of bent starlight and find the places where space folds deeply. Each curve is a clue, each distortion is a footprint. And yet the strangest place of all is the photon sphere, a thin, ghostly shell just outside the event horizon where light can orbit the black hole endlessly. It is not a safe place. Even the tiniest nudge can send a photon spiraling inward or flying outward. But in theory, it is a place where light can remain forever, circling in perfect silence, not falling, not fleeing, just caught, a mirror without reflection, a ring without song. These ideas stretch our minds. They ask us to see light not as eternal, but as vulnerable, not as limitless, but as shaped by gravity's dream. And in that shaping we discover truths not just about black holes, but about light itself, that it can carry a story even when it disappears, that it can leave behind patterns, echoes, and shadows, that its silence too can speak. In recent years, the Event Horizon Telescope gave us our first glimpse of this boundary. We saw the shadow of a black hole, not directly but through the glow of its accretion disk, through the photons that just barely escaped. That shadow was not empty. It was full of presence. It showed us where light could no longer return, and in doing so it drew the shape of the invisible. This is how we learn. Not from what light tells us loudly, but from what it cannot say, from what it almost escapes, from the path it takes before it falls, from the way it curves and changes colour. In the quiet near a black hole, light becomes something more than brightness. It becomes a map of gravity, a whisper of space's true shape, a lesson in how even the fastest, freest thing must sometimes bow to silence. So when we think of light that never returns, let us not feel loss. Let us feel wonder, that it tried, that it taught, that in falling it told us everything we needed to know about what lies beyond the edge. Now let us drift gently to the final place where light and gravity share their quiet story. It is here, just beyond the edge of knowing, where the last beams of light lean toward the black hole and vanish. Not in anger, not in fear, but in surrender, soft, steady and complete. And in that surrender there is no pain, there is only silence, the kind of silence that listens more than it speaks, the kind of silence that remembers everything that came before it. Black holes do not pull in light with violence, they do not reach or chase, they let space itself curve so deeply that light has no other path. That is the quiet truth. Space near a black hole no longer points outward. Every direction is inward. Even if light tries to move away, the very shape of space carries it back. It is not captured. It is accompanied, not stopped, but redirected forever toward the heart of gravity's dream. Inside the event horizon, time itself changes shape. We cannot truly say what happens there, not with certainty. Light does not return, and neither do signals. To an outside observer, it looks as though time slows at the edge, like a long breath held for eternity. The final flicker of a falling photon stretches and dims, frozen in view. But to the photon, time moves on, its journey continues. It crosses the horizon and travels into the unknown. Where does it go? We do not know. Perhaps it approaches the singularity, a point where all matter is crushed into infinite density. Perhaps it becomes part of the black hole's mass, contributing to its quiet growth. Perhaps, as some scientists imagine, the information carried by that light is not lost at all, but hidden on the surface of the horizon itself, stored in a way we do not yet understand. This is the paradox that troubles physicists and inspires poets. What happens to the information carried by light when it falls into a black hole? In our universe, information is meant to be preserved. Nothing should disappear completely. Yet a black hole seems to suggest otherwise. And so we ask again and again, does the story of a light end at the event horizon, or does it continue, changed, hidden, whispered? We have not yet answered this question, but even in our not knowing we learn something profound. That light, like truth, can be changed by where it travels, that its story depends on the shape of the space it moves through, and that the deepest truths may not shine, they may simply exist, quietly shaping what surrounds them. Even now, as telescopes peer into distant galaxies, we find new places where light comes close and never returns. Supermassive black holes, millions, even billions of times more massive than our Sun, rest in the hearts of galaxies, shaping their stars with invisible hands. We see their glow not in light that escapes them, but in the light that tries, in the heat of swirling gas, in the bent paths of background stars, in the sudden quiet where something once bright has disappeared. And here, too, near our own galaxy's centre, Sagittarius A waits, not feeding, not glowing, but holding. Its presence is known through the motion of stars that dance around it, moving in tight, fast orbits, drawn by a gravity that does not shine. If one of those stars strays too close, its light may someday vanish, not in an instant, but in a long, slow fall into silence. This is the legacy of black holes. They show us not only what happens to light, but what light means, that it is not invincible, that it follows the same rules as everything else, that it can be stretched, slowed, even shinsed. And still, in the way it bends and fades, it leaves behind a story. So let us return once more to the title of this tale. When light comes close but never returns, it is not the ending that matters most. It is the path, the curve, the colour, the effort, The way light leans toward gravity and becomes part of something larger, something invisible, something still. And in doing so, it reminds us of something important. That what is seen is only part of the truth. That what disappears may still have meaning. That even in Hainsun, the universe speaks. A black hole does not ask for light. It does not demand. But when light comes close, it becomes something new. And though we may never see where it goes, we carry its story in every shadow, in every echo, in every curved path that remains behind. So the next time you look up at the stars and feel the warmth of their light, remember that some light does not reach us. Some light falls into silence, and that silence is not empty. It is full of gravity, full of wonder, full of a dream that bends space and holds time patiently in the quiet heart of everything. Stars do not live forever. Though they burn for millions, even billions of years, they too must one day rest. Their light, so constant and full, is not endless. It is a process, a careful balance between the pull of gravity inward and the push of energy outward. When that balance is lost, the star begins its quiet fall. Not all stars go gently, but some do, and their breath near the end is slow and deep like the final exhale before sleep. In that stillness, something strange and beautiful begins. A star begins to die, not with a scream, but with a sigh. Imagine a giant star many times heavier than our sun. For most of its life, it fuses hydrogen into helium, then heavier elements, layer by layer, in its core. This fusion pushes outward, keeping gravity at bay. But eventually the fuel runs out, the fusion slows, the outward pressure fades. Gravity, which has waited patiently all this time, begins to win. The star begins to shrink, to fall inward upon itself. At first, the outer layers resist. They puff outward, expanding into space. The star becomes enormous, a red supergiant glowing dim but wide. Its breath becomes uneven, like the rise and fall of an ocean wave. It sheds gas, it cools, it pulses, and all the while the core grows heavier, tighter, and darker. Inside, iron begins to form, an element that does not release energy when fused. With no more fuel to push against gravity, the core collapses, suddenly, completely. What happens next depends on the size of the star. Some stars explode in a final act of brilliance, a supernova. This explosion sends shockwaves across space, seeding the galaxy with elements needed for life. Carbon, oxygen, iron, gold. It is in these explosions that the universe spreads its gifts. But at the center of the blast, the core keeps collapsing. It does not stop. It becomes something else. If the remaining core is heavy enough, it will keep falling inward until it forms a black hole, a point so dense, so curved that even light cannot escape. A place where the star's breath ends and gravity's dream begins. This is not destruction, it is transformation. The dying star becomes the seed of a silent presence. A sleeping giant is born from the final breath of a sun. And though the star is gone, something remains. Around the new black hole, the material that didn't fall in begins to swirl. Gas and dust form a disk. Some of it escapes into space. Some of it heats and glows. Some of it spirals inward, feeding the black hole slowly. These are the leftovers of a life once full of light, now moving into silence. Not lost, but changed. Not broken, but resting. We often imagine death as an end, but for stars it is part of a cycle. Their quiet breath gives rise to new clouds, new stars, new planets. The iron in your blood was born in the heart of a dying star. The calcium in your bones, the oxygen you breathe. These were once the whispers of stars that lived and died long before Earth was born. And some of those stars ended not with a puff, but with a fall into darkness, a gentle collapse into stillness. This is how the universe works. It builds with fire and ends in shadow. It moves between light and silence, always continuing. And black holes are not the villains of this story. They are the listeners, the resting places, the final verse in a long, glowing song. They do not take more than the star gives. They do not reach. They simply receive, holding space where light once danced. So let us pause here, beside a dying star. Let us listen to its last breath. It does not cry out. It does not panic. It cools. It spreads its layers. It folds inward. It becomes smaller, then quieter, then silent. And at the center of that silence, something new begins to form. Not a light, but a pull. Not a glow, but a gravity. not an end, but a waiting. And that waiting becomes the black hole, a reminder that even the brightest stars must rest, that even the longest lives must slow, that silence too is a part of the sky. Let us follow the story deeper now, into the space left behind by the star's final breath. The explosion has faded, the light has dimmed. What remains is a stillness so dense it bends time itself. At the heart of that silence lies the black hole, born from the inward fall of the star's core. It is no longer a place of fire, no longer a fusion engine lighting the sky. It is now gravity in its purest form, quiet, complete, invisible. And yet the story does not end here. Around the black hole a disk of glowing gas may still form, bright and hot, spiralling slowly inward. This gas is the last of the star's outer layers, too slow to escape, too light to resist. It warms as it falls. It releases light, brief, sharp, golden, before it vanishes forever. These moments can be seen from Earth, through telescopes that capture X-rays and soft flickers in the dark. They are the star's final signals, echoes of a breath that once warmed distant planets. But for many black holes, even these disks fade. Left alone in space, they become quiet. No more gas, no more light, only gravity, waiting, still. These black holes wander through space like forgotten thoughts. They have no need to move, no need to glow. Their presence alone curves the space they pass through. A planet could orbit one without ever seeing it. A star could pass nearby unaware. The black hole would feel everything but say nothing. The most massive stars become the most massive black holes, but smaller stars, stars like our Sun, end in quieter ways. They do not collapse into black holes. Instead, they shed their outer layers slowly, like a snake shedding skin. Their cores cool into white dwarfs, small, dense, glowing embers of what they once were. Over trillions of years, even these embers fade, becoming black dwarfs, cold, quiet relics in the dark. They do not fall inward, they do not bend light, but they too are part of the same breath, the same slow ending. Still, for the heaviest stars, the path inward is unavoidable. Their gravity is too strong, their collapse is too complete. They skip the glowing ember stage. They fall directly into the silence of a black hole. And in doing so, they give shape to one of the universe's most mysterious places. A place not defined by what it shows, but by what it hides. Inside a black hole, time may end, or change, or continue in a way we cannot describe. We cannot see it. We cannot follow it. But we know it is there because we feel its pull from outside. We see how stars move differently when a black hole is near. We measure their orbits. We observe their light. We follow the patterns, the paths, the ripples. And always, at the centre, we find a silence. This silence is not empty. It is full of memory. It is the shape of everything the star once was, its mass, its spin, its motion. These things are not lost. They are stored, encoded in the black hole's presence. A kind of cosmic fingerprint pressed into the fabric of space, and still the story deepens. When two stars die near each other, and both become black holes, they may spiral together slowly, like dancers in a vast invisible room. Their gravity sings a song too low for us to hear with ears, but not with machines. When they merge, they send out gravitational waves, ripples in the structure of space itself. These waves pass through galaxies, through dust, through time, and sometimes through us. We have heard them now. Not long ago the first wave arrived, an echo from a black hole merger billions of years in the past. It shook the detectors on Earth ever so gently, like the touch of a single falling leaf. And in that touch was a story. Two dying stars, two collapsing cores, two quiet giants becoming one. All of it began with a breath, a long, slow breath of a star nearing its end. A breath that became a collapse that became a silence, and that silence became a black hole. We live in a universe shaped by these stories. The atoms in our bones came from stars that breathed and died. The gold in our rings was forged in explosions so bright they outshone galaxies. The space we drift through now is curved not only by the light of living stars, but by the gravity of those that fell into sleep. So let us not fear the end of a star. Let us honor it. Let us see the black hole not as a grave, but as a gate, a place where energy becomes a memory, where mass becomes presence, where the long breath of a dying star becomes the heartbeat of a new, silent center in the sky. Now let us return to that breath, the slow, final exhale of a dying star, and follow it to its quiet conclusion, not in flashes or flames, but in folds of gravity so deep they cradle light itself. For when a star dies into a black hole, something continues. It is not the star's brightness, not its shape or warmth, but something more quiet, a kind of remembrance. The space around it remains bent. The gravity it gave to the world does not vanish. It becomes a stillness that reaches across time. We look up at the night sky and see stars shining as if forever. But behind some of those lights, and in the spaces between them, are the remains of those that have already gone. Their energy has rippled outward into dust clouds. Their mass has folded into suns, and their legacy, what they gave to the universe, shapes new beginnings. From their remains, planets will form, oceans will rise, life, perhaps, will blink into being, all because a star breathed deeply and then breathed no more. Black holes, in this sense, are not just the end of stars. They are part of a larger pattern, a cosmic cycle of becoming, a rhythm that flows from light to silence and back again. Stars burn because gravity holds them. They collapse because gravity waits. They end because gravity remains. And when they become black holes, they continue the story, not as fire, but as form, not as light, but as memory held in the curve of space. What happens inside we do not know. Maybe the core collapses to a point. Maybe space becomes so tight it turns into something else. Maybe all the information of the star is kept on the surface of the horizon, like a hidden language. Scientists imagine, they model, they wonder, but the black hole keeps its secret. Its silence is firm. And yet it is not a refusal. It is simply the natural end of something that began with fusion and warmth and wind. And just as stars can collapse, galaxies can too, on grander scales and longer times. Some believe that in the far future, when the last stars have faded and the universe has grown dark, only black holes will remain, scattered like pebbles across the cosmic ocean, still and steady, holding what is left of everything that once glowed. And even they may slowly fade, not in explosions, but in evaporation, particle by particle, in a process we call Hawking radiation. It is a long goodbye, a final breath of the final breath. But we are not there yet. We live in a universe still lit by stars, still warmed by fusion, still growing. And black holes are part of that growth. They shape galaxies. They guide stars. They teach us about time and space and endings that do not erase but reshape. In their presence we learn to see silence differently, not as absence but as continuation in another form. If you could float near a black hole, safely, quietly, you would not see chaos. You would see motion. Calm, curved paths of light, orbits of stars, dust flowing like water into a dark pool. You would not hear a sound, for space has no voice. But you would feel the weight of history, the pull of all that has come before. The black hole does not demand attention. It does not chase or cry. It waits, and in its waiting it holds everything close. And maybe, in this way, black holes are a kind of memory, not of events, but of presence. A memory of a star's weight, a memory of its spin, a memory of the space it once filled, now folded into a quiet core. They are not empty. They are full of what once was. They are not cruel. They are honest. They tell us the truth that even light must someday rest, that energy must change form, that everything moving will one day become still. So let us leave this story where it began, with the breath of a dying star. It does not shout. It does not burn forever. It becomes something else, a black hole, a curve in space, a whisper of gravity that will last longer than any flame. It is not an end. It is a transformation. It is the universe continuing in silence, wrapped in the gravity of something that once gave light and now gives shape. And perhaps that is the greatest legacy of a star. Not just the light it gave, but the silence it left behind. A silence that curves space, a silence that teaches, a silence that waits, quietly breathing even now in the deepest parts of the sky. There is a place in the universe where the known fades into the unknown, a place not made of matter or light, but of boundary, an invisible edge where physics falters and certainty ends. This place is the event horizon of a black hole. It is not a surface, not a wall, but a moment, a line drawn in the fabric of space where escape becomes impossible and even time begins to bend. From this edge no message returns, and yet in the silence that follows, we hear something faint, a ripple, a shift, an echo. Black holes do not speak, they do not shine, but when something crosses the event horizon, it leaves behind more than absence. It leaves behind evidence, a star stretched into ribbons, a gas cloud lit for a final breath, a gravitational wave, a soundless tremble in the space. These echoes do not come from inside the black hole, they come from its edge, the last place where time and light can still reach out. Imagine space like a pond. A falling pebble does not just vanish, it creates ripples. The black hole's edge is where the pebble falls, but the ripples move outward. They carry the shape of what has fallen, the energy, the motion, the memory, and we, far away, can feel those ripples, across time, across space, across the vast, quiet dark. Gravitational waves are one such ripple. When two black holes spiral together and merge, they send out these waves, bending space itself. Not with explosions or fire, but with gentle stretches and compressions. We cannot see them, we cannot hear them with ears, but we can feel them, with instruments built to listen to the quietest shift. A movement smaller than an atom, a signal older than Earth. These waves are the echoes of collisions that happened billions of years ago. They pass through us unnoticed. They move through the Earth, the moon, our breath, our bones. They tell a story not of destruction, but of unification. Two silent objects becoming one, their masses joining, their spins aligning, their gravity deepening. But there are other echoes too. Faint light from gas before it falls, flickers of X-rays, pulses from matter swirling in the last orbit. These are signals from the brink, from the edge of nothing. The black hole does not send them. The space around it does. And from those signals, we learn the most. We learn how fast the black hole spins, how heavy it is, what direction it leans, what it has consumed. All without ever seeing inside. The edge becomes our mirror, our teacher, our guide. It reflects not images, but behavior, not forms, but forces. And in that reflection, the black hole gives us the gift of understanding without revealing itself. Even the smallest black holes, formed from stars, have edges that whisper. When a star collapses, it may flare in gamma rays, bright, short bursts that stretch across galaxies. These too are echoes, not from the center, but from the event itself, the fall, the fold, the moment the horizon is formed. These brief flashes light the sky for just seconds, but their origin is a black hole's first breath. And so the edge of a black hole is not silence alone. It is a place where silence begins, but before it does, there is motion. There is change. There is light trying to escape, matter twisting, stretching, folding. The echoes we receive are not ghosts, they are real. They are measurable, they are precise, and they are soft, like a memory told across the wind. We build telescopes that link across continents to catch the faint curve of light around a black hole's edge. We listen to gravitational waves from space with laser beams in long tunnels. We model the flow of gas in spirals too fine for the eye to follow, all to hear the echoes, all to learn what lies near the edge of nothing. The black hole's interior remains closed to us, but the edge remains open, and at that edge, the universe speaks, not in voices, but in shifts, in trembles, in flickers, in ripples that take billions of years to reach us, and when they do, we understand not just the black hole, but the patience of space itself. Because even when nothing escapes, something always remains, an echo, a curve, a reminder that the edge of silence is not empty, it is full of the final stories of light and time. Let us move now along the edge itself, where space folds gently inward and time begins to stretch. This edge is not hard. It does not resist like a wall or push like wind. It is soft, invisible, defined only by behavior. For light, it is the last place from which escape is possible. For matter, it is the final point where movement still carries a future. Beyond it, the path curves inward so deeply that all directions lead to the center. But just before that fall, just before the silence, there is motion, there is change, and those changes ripple outward into the universe. These ripples are not like waves on a sea, they are changes in space itself. Gravitational waves are among the quietest things in the cosmos, and yet they hold the loudest truths. When black holes merge, space does not explode, it rings. Like a bell struck not with a hammer, but with memory. Each wave carries a signature. The masses of the black holes, the rhythm of their dance, the angle of their spin. These are not guesses. These are facts written into the wave itself. For billions of years these waves travel. Through gas, through dust, through void. They do not fade, only stretch like a slow breath across a long room. And then they reach us. Quiet, small, but clear. The instruments that detect them are patient and precise, waiting for the movements smaller than atoms. When a wave passes, space itself grows slightly longer, then shorter, like a heartbeat too slow to hear. And in that heartbeat, we learn what happened and when and how. These waves are not the only echoes. There are electromagnetic echoes too. Light that curves, light that flares, light that stretches. When matter falls toward a black hole, it heats up. It glows. It releases X-rays, ultraviolet rays, sometimes radio waves. These lights come from the edge, not inside. They are from the moment just before falling. They flicker. They pulse. They fade. But they carry a record. They show us the energy of the fall, the shape of the spin, the hunger of the horizon. And then there are echoes we cannot measure directly, but we see their effects. Stars that wobble near something invisible. Gas clouds that stretch and spiral for no reason, except that something large, dark, and still is nearby. The absence of light where we expected brightness. These are shadows. These are hints. These are the outlines drawn by gravity around a silence. In recent years, astronomers have searched for what they call echoes of echoes, reverberations in data, small repetitions in signals from black holes that suggest something more complex than we thought. Could these be signs of structure at the edge? Could the event horizon shimmer slightly, affected by quantum forces? We do not know, but we are listening. Some theories suggest the horizon might not be a perfect line, but a region, a fuzziness, a haze where particles blur and laws blend, where quantum physics and gravity meet and do not agree. This is the frontier of understanding, the meeting of the very large and the very small, the known and the unknowable, the silence and the echo. Black holes challenge our deepest assumptions. They force us to ask, is information ever truly lost? If something falls into a black hole, does its story vanish completely? Or is it stored somehow, on the edge, in the spin, in the mass? Stephen Hawking proposed that black holes may emit radiation, slowly leaking away their mass over trillions of years. This Hawking radiation, if real, is another kind of echo, a final whisper of something that once was. But this radiation is too faint to detect, at least for now. It would take longer than the current age of the universe for a large black hole to fade in this way. And yet, the idea remains, that even from the edge of nothing a quiet release continues, that even the most silent presence is not truly still. The universe, it seems, is never truly quiet. Even in the deepest dark, even at the edge of the most silent object, there are tremors, flashes, curves, and in each a story unfolds, not in voice but in motion, not in brightness but in the change of space itself. So when we speak of echoes from the edge of nothing, we speak not of sound but of evidence, of messages written in the very shape of the cosmos, of waves and particles and light, all changed by proximity to silence. And those changes, those gentle shifts, are enough to rebuild the story, to understand not just the black hole, but the universe that surrounds it. And so we listen, not with ears, but with tools, with lenses, with patience. The black hole will not shout, it will not explain, but its edge continues to speak, in ripples, in rays, in echoes that carry across time and touch us gently here on Earth. And in that touch, we are reminded that even silence leaves a mark. Now we arrive at the final edge, not of a black hole, but of understanding itself. The event horizon, silent and unlit, marks not just the border of a collapsed star's gravity, but the boundary between what we can know and what we can only imagine. Beyond it, the rules we've tested no longer apply with certainty, and yet, just before that veil, the universe still speaks. It whispers in patterns, in pulses, in ripples that stretch across space and time. These are the echoes from the edge of nothing. Every black hole we observe, we know only through what happens near this edge. Not within, never within, but the edge tells us everything it can. And what it tells us is layered and strange and beautiful. The final orbits of gas before it vanishes, glowing so hot they paint the sky in X-rays. The sudden jets of energy that shoot from the disk's poles, narrow and fierce, though the core is silent. The faint tremble of a gravitational wave that reaches Earth after travelling undisturbed for 1 billion years. These are not fantasies, they are facts, measured, mapped, understood, yet still mysterious. Even the idea that black holes might eventually fade does not erase these truths. The slow leak of Hawking radiation, if it exists, is so quiet that no telescope today can hear it. But it suggests something profound, that even the deepest silence may hold motion, that even the edge of nothing may not be still forever, that something escapes, not in rushes but in whispers too faint for now. And that brings us to another kind of echo, the echo in ourselves, in our need to understand, to listen, to build instruments that detect what we cannot touch, to imagine what lies beyond the visible. Every time we hear a gravitational wave or catch the flicker of an orbiting gas stream, we are hearing the end of a journey that began in silence. We are witnessing the final turn of matter around a place it will never leave. We are standing at the limit of what light can do, and still finding meaning there. This pursuit is not just scientific, it is poetic, it is ancient. Humans have always looked for meaning in the dark, in the spaces between stars, in the pause between beats. Black holes are the modern version of that search, places that do not show but still reveal, objects that do not glow but still guide, and from their edges we gather not only data but wonder. Some researchers now believe that the surface of a black hole, the event horizon, may not be empty at all, that it might store information in quantum bits, in fine details of spin and mass and time, that the surface is not smooth but rich, that everything that falls in leaves a kind of fingerprint, that no story is truly lost, only transformed, hidden, folded into space itself. If true, this would mean that the universe remembers, even at the edge of forgetting. And that thought is a kind of echo too, a gentle return of something once gone, a suggestion that even endings are not as final as they seem. So we continue to listen, through telescopes on mountaintops, through mirrors buried underground, through beams of light bounced across continents. We search for the tiniest shifts, the faintest curves, the smallest ripples, because we know that at the edge of nothing the universe is still telling its story, softly, repeatedly, with care. We may never cross that edge, not with ships, not with probes, not with the instruments we know today, but we do not need to. We learn from the edge because the edge is where the world changes, where light turns inward, where time slows, where silence begins. And it is enough to stand near that place to hear the echoes and to know that the silence beyond is not empty. It is simply unreadable, not void but full of presence too deep to touch. The black hole remains quiet, but the space around it sings. And in that song are clues to the shape of time, to the fate of stars, to the secrets that gravity keeps close. So as we leave this story, remember this. Even from the edge of nothing, something always comes back. A ripple, a shimmer, a trace. The universe never speaks louder than when it whispers through its silences, and those who listen patiently enough will hear everything. All across the universe there are forces we cannot see but always feel. Gravity is one of them, a quiet presence that holds everything in its place. It does not need light, it does not make sound, and yet it shapes the dance of galaxies, the fall of apples, the tides of oceans. We live every second in its arms, often without noticing. This is the gentle pull of invisible things. Gravity is strange because it is everywhere, and yet it has no colour, no scent, no texture. You cannot touch it, but you can feel it. You cannot hear it, but you live by its rhythm. Planets circle stars not because they choose to, but because gravity calls them into motion. Moons stay near their worlds because gravity binds them close. Black holes, perhaps the most intense form of gravity, hold even light itself in their curve. And yet gravity is not the only invisible thing. Time, too, is unseen. We cannot hold it, cannot store it, cannot pause it, but it moves through us all. It pulls us forward second by second, hour by hour, moment by moment. Space is invisible too. We look into the night sky and see stars, but between them is space, vast, dark, stretching far beyond what light can reach. It holds everything together, though it appears to hold nothing at all. Black holes bring all of these invisible things together. They bend space, they slow time, they embody gravity so completely that even the fastest traveller, light, cannot break free. But they do this quietly. They do not burn, they do not shake, they simply pull, softly, relentlessly, invisibly. When we look into a galaxy and see stars moving in ways we cannot explain, we begin to suspect something unseen is nearby. When stars whirl too quickly, when gas stretches into spirals, when nothing visible accounts for the motion, we look deeper. We search not for what shines, but for what bends. And in that bend we find a presence, something with weight but no form, something dark but not evil, something still but powerful. This is the nature of invisible things. They do not announce themselves, but their effects are everywhere. Like the wind, they are known by what they move. Like a whisper, they are felt in silence. Black holes, dark matter, gravity, time, each one shaping the world from behind a curtain of quiet. And so we must learn to see differently. Not only with eyes, but with instruments, with minds, with patience. We build telescopes that measure the flicker of starlight, detectors that feel the stretch of space, computers that map unseen curves, and through all of this, we learn to read the language of invisible things. It is not a language of words, it is a language of movement, of pause, of orbit, of disappearance and delay. A star dims not because it fades, but because something passes before it. A planet wobbles not because it is unsure, but because another gravity touches it. A light bends not because it is broken, but because space itself leans under the weight of something we cannot see. This is how we discover. Not by what shouts, but by what shifts, not by what glows, but by what guides. And perhaps there is something comforting in this, that the strongest forces do not need to be seen to be known, that we do not need to hold something to feel its presence, that even in the deepest dark there is a shape, a reason, a pull. Black holes remind us of this truth. They do not shine, they do not speak, but everything near them moves in quiet patterns. Stars speed up, light curves, time stretches, they draw galaxies into spirals, hold their centres like anchors buried in deep soil. They ask for nothing, they demand nothing, and still they are obeyed. This is not fear. This is not danger. It is order, balance, a soft kind of power that never raises its voice. And so we orbit, not just around stars, but around ideas, around gravity, around the invisible frameworks that make motion possible. Every planet, every moon, every particle of dust plays its part in this quiet choreography. And behind it all, beneath it all, pulling gently, invisibly, faithfully, is the unseen force that holds the universe together. The gentle pull of invisible things. Let's move closer now to the quiet forces that shape our universe, the ones we cannot touch or see, but which move us just the same. Gravity is not loud, it does not flash or burn, yet it holds galaxies together like threads in a vast, invisible net. The gentle pull of invisible things is not weakness, it is persistence, patience, the kind of power that needs no sound to be felt. We see this in black holes. These are not objects in the usual sense. They are places where space curves so steeply that everything falls inward, even light. Their presence is known not through their own glow, but through their influence on what surrounds them. We find them by noticing how stars behave strangely near certain places. They orbit faster. Their paths curve more sharply. There is no star there, no planet, no visible mass, and yet something is holding them. Something silent, something strong, gravity in its purest form, and this same pattern appears again and again, in the centres of galaxies, where supermassive black holes live, in the collapse of massive stars where small black holes are born, in binary systems where a black hole quietly sips gas from a nearby star, causing that star's light to flicker and pulse. We do not see the black hole itself, but we see the ripple it makes in the light, the echo in the orbit, the shadow in the pattern. And beyond even this, we see hints of something more, dark matter. It is not black holes. It is not gas or dust. It does not shine or absorb, but its gravity shapes the motion of galaxies. Without it, the stars on the outer edges of galaxies would fly off into space, but they stay. They spin in place faster than they should. Why? Because something invisible holds them. Not just black holes, not just ordinary matter, but something else, something dark. Not because it is evil, but because it does not interact with light. We call it dark matter because we do not know what it is, but we know what it does. It is another gentle pull, vast, slow, constant. A presence known by its absence of light but fullness of gravity. It makes up most of the matter in the universe. We cannot see it, but without it the structures we know would not exist. And perhaps this is the deeper truth of the cosmos, that not everything important is visible. That light is only part of the picture. The universe is not made only of stars and planets. It is made of curves, of time, of forces we cannot see but which keep everything in place. We are used to trusting our eyes, to believing what is bright must be powerful, but the black hole does not shine, the dark matter does not glow, and still they rule the shapes of galaxies, they guide the paths of stars, they write the story of motion in the sky. Our instruments now stretch to find these things. Telescopes measure the bending of light near unseen mass. Detectors search for particles that rarely touch anything. Simulations on supercomputers trace the growth of the universe under the pull of invisible matter. We are learning to see without seeing, to find truth in the quiet influence of things we cannot grasp. And this isn't only true in the sky. On Earth too, the invisible is always with us. Gravity holds our feet to the ground. It draws the oceans toward the moon. It keeps the air wrapped around our planet. We do not wake each morning and thank gravity. We do not marvel at its constant attention. But it is there, every second, in every breath, in every heartbeat. Time too passes quietly. It moves forward no matter how still we are. It pulls us along gently, never stopping, never rushing. We feel it only when we look back, when we notice change, but its presence shapes us. And in this way, perhaps black holes are not just cosmic mysteries. They are reminders. They show us what it means to be felt but not seen, to guide without noise, to change everything by simply being where they are. They teach us to trust in forces beyond our senses, to look for meaning in motion, to believe in the structure of things that do not sparkle, because even in darkness, even in silence, there can be form, there can be purpose, there can be strength. So when we speak of the gentle pull of invisible things, we are not only describing gravity or black holes or dark matter, we are describing a principle of the universe itself, that what matters most is often unseen, that what lasts the longest may be what we never directly notice, that in the quiet, patient forces of space and time, we find the shape of everything we know. Now let us follow that gentle pull one last time into the heart of silence where the invisible becomes undeniable. The black hole sits in space like a still breath, not demanding, not glowing, and yet it holds its galaxy in balance. Around it, stars orbit in long looping arcs, following a force they cannot see. The gas swirls, the dust spirals, the light bends, and all because something silent is there, something with no edge, no sound, no face, just presence. This is the lesson that black holes teach best, that true power can be still, that the universe is shaped not just by what shines, but by what steadies. In a cosmos of brightness and fire, it is gravity, calm, patient, invisible, that keeps everything moving in order. It does not argue with light, it does not resist motion, it simply waits, and in waiting, it directs. And yet this force does not need to be large to be felt. A black hole may be many times heavier than our sun, but the Earth too is heavy enough to hold the moon. A spoonful of neutron star weighs as much as a mountain, but it does not glow. A planet's orbit is quiet, perfect, continuous. These are the movements we rarely see but always live within, the pull of the unseen, the influence of the quiet. So what do we make of all these invisible things, black holes, dark matter, gravity, time? We cannot hold them, we cannot bottle them, but we build our lives around them. Without gravity, there is no orbit. Without time, there is no story. Without space, there is no place to be. And maybe this is not just science. Maybe it is also something human. We are drawn by things we cannot name. We follow memories. We believe in futures. We feel love, hope, curiosity, none of which we can measure like light. But they guide us all the same. They are our own invisible pulls, and they shape us as surely as gravity shapes a galaxy. The black hole, then, is not a hole at all. It is a point where space is shaped by memory, where time stretches toward quiet, where matter folds into itself not to vanish but to become something deeper, something that reminds us that silence is not the absence of meaning. It is the beginning of wonder. We often speak of black holes as endings, the end of a star, the end of light, the end of information. But perhaps they are something else, places where beginnings and endings blur, where what falls is not lost but changed, where invisibility is not erasure but transformation. The gentle pull of a black hole is not to destroy but to reshape, to gather, to remind. And this too applies to the way we understand life. The things we do not see often shape us more than the things we do. The memories we carry, the love we feel, the thoughts we do not say, the choices we do not understand until later. These are our black holes, the quiet centers of our stories. They do not shine, but they hold us. So the next time you look at the sky and you see the stars sparkling like scattered seas, think about what you do not see. Think about the space between. Think about the gravity at the center. Unseen but essential. That is where the black hole lives. That is where the spiral finds its rhythm. That is where the invisible does its work. And feel comfort in knowing that not all truths need to be bright. Not all forces need to speak. Some just are. They surround us. They guide us. They move the heavens with the lightest touch. This is the gentle pull of invisible things, the quiet presence at the center of motion, the silence beneath the song, the hand we do not see but always feel. Time flows around us like an invisible river. We cannot see it, yet we move with it. We count it in days, in breaths, in stories told before bed. It never stops. It never turns back. But near a black hole, something changes. Time, that steady river, begins to slow. Not because it is tired, not because it forgets, but because space itself bends so deeply that time follows. And in that curve, time begins to fall asleep. Imagine floating far from any planet or star, surrounded only by the hush of space. Your clock ticks evenly, your heart beats softly, but as you drift toward a black hole, the rules begin to shift. From your point of view, nothing feels different. Seconds pass like they always do, but if someone watched you from far away, they would see something strange. They would see you slow down, not your movements, but your time itself. You would seem to move through syrup, each moment stretched thin. You would wave, but your hand would rise slowly. You would blink, and they would see it last forever. This is not a trick. It is not an illusion. It is a truth of gravity. The stronger the pull, the slower the time. A black hole's gravity is so strong that it presses time flat near its edge. At the event horizon, time nearly stops, at least from the view of someone outside. To fall toward a black hole is to move forward while the rest of the universe races ahead. You begin to drift into a kind of forever, where every heartbeat echoes longer than the one before. Scientists call this gravitational time dilation. We already see it on Earth in small ways. Clocks on satellites tick a little differently than those on the ground. Time changes with altitude, with speed, with gravity's pull, but near a black hole the effect grows vast. A single hour near the edge could pass while centuries flow by elsewhere. A person hovering just above the horizon might return to find that everything they knew has grown old, and yet to them nothing changed. This slowing of time is not something we can feel. It does not tug or weigh or burn. It is silent. It is smooth. It simply happens because time and space are woven together and gravity pulls on both. A black hole, then, is not just a place where matter collapses. It is a place where the fabric of the universe folds so tightly that time itself is drawn inward. We often imagine black holes as hungry beasts, swallowing everything that comes too close. But what if they are more like deep dreams? Not monsters, but moments where time goes quiet, where the tick of the clock softens until it becomes a hum, then a pause, then a hush. In this way, black holes are not only about endings, they are about the deep resting places of time. Even light cannot escape. It tries to climb away but finds that time has grown too slow to carry it. It lingers near the edge, stretching into red, then dark, then gone. And yet, for a moment before it disappears, that light tells us something. It shows us where time bends. It traces the curve of the invisible. It marks the place where sleep begins. Some scientists believe that inside a black hole, time and space may switch roles. That time becomes a direction like space, and space becomes something strange and new. We do not know. The equations break down, the numbers drift into mystery, but the idea remains that inside a black hole, time is no longer what we think. It falls inward. It rests. It curls like smoke into the dark. And so we return to our thought. What does it mean for time to fall asleep? It means that movement continues but the moments stretch. It means that the future grows distant and the past fades. It means that what was fast becomes slow and what was clear becomes calm. A black hole is not loud, it does not scream, but it cradles time in its silence. And in that cradle, time does not vanish, it dreams. If you could hover just above the event horizon and look out, you would see the universe moving faster. Stars would spin more quickly, galaxies would age, light would shift through colours and vanish, and you would remain, watching, waiting, still. This is the strange gift of gravity. It does not just pull, it changes time, and in its deepest pull, time folds inward and begins to rest. This is the place where time falls asleep, not broken, not gone, just slowed into softness, curled into curves, held in the arms of gravity's endless hush. Let us drift deeper now, into the space where time begins to stretch like thread pulled across centuries. Imagine a clock falling slowly toward a black hole. To the clock itself, its hands move steadily, faithfully marking each second. But to someone far away, those hands begin to slow, as if reluctant to reach the next moment. Each tick becomes quieter, each second longer, until, from that distant perspective, the clock seems to stop, frozen just above the black hole's edge. But the clock does not know it is slowing. Inside its quiet frame, time feels normal. This is the paradox of black holes. Time inside continues, but to the outside world it appears to fade away. The deeper one moves into the pull of the black hole, the more time stretches. This is not just a theory. It is a measured fact. When light escapes from near the event horizon, it is redshifted, its energy stretched, its message slowed. What was once bright becomes dim. What was once quick becomes drawn out. The black hole does not block the light. It changes the way it leaves. It transforms time into distance and distance into silence. Even the matter around the black hole follows this slow rhythm. Gas and dust falling inward spiral in luminous circles. They form accretion disks, whirlpools of glowing material that rotate at incredible speeds. And yet, as they near the horizon, their light begins to fade. It lingers at the edge, where time has slowed so much that the moment of falling seems to last forever. Call it the last photon orbit, the closest point where light can circle the black hole without falling in. It is a place of eternal hesitation, where time clings to the edge. This slowing becomes even stranger when we consider black hole mergers. Two black holes spiraling toward each other do not collide suddenly. Their dance is slow and patient, like a breath held between notes. As they draw near, space itself begins to ripple. These ripples are gravitational waves, gentle stretches in the fabric of the universe. When they pass through Earth, they change the distance between atoms by less than the width of a proton, and yet they are loud with meaning. They are the sounds of time falling asleep, recorded in the rhythm of gravity. When the black holes finally merge, the result is a new black hole, larger and quieter. The space around it still ripples, but the echo fades. What remains is the deepest calm, a silence that is not empty but full of curves, a place where all directions bend inward, where all clocks slow, where all paths point not forward or backward, but inward, into time's quietest state. Inside the black hole we do not know what happens. We cannot see, we cannot hear. But equations suggest that time does not move as it does here, that instead of flowing it folds, that instead of passing it waits. Some physicists wonder if the singularity, the point of infinite density at the centre, is a place where time ends. Others suggest that it's not an end, but a doorway, that what falls inside continues, not in our time, but in some other form of time. a time that is not marked by seconds or seasons, but by gravity's deeper rhythm. This idea is not new. For centuries, humans have wondered what lies beyond the limits of time, what happens after the final moment. Black holes bring that question into the realm of science. They are natural clocks that slow with mass, natural edges where time itself begins to soften. In their presence, we confront a version of time that is not ours, a time that listens instead of moves, that curves instead of flows, that holds instead of hurries. Even near Earth, we feel this in smaller ways. The satellites that orbit our planet must adjust their clocks to account for the difference in gravity. If we did not correct this, GPS systems would drift by miles each day. This is how real the bending of time is. This is how sensitive the universe is to gravity's pull. And near a black hole, that sensitivity becomes complete. So let us imagine again the person hovering near the event horizon. They look outwards and see stars rushing through their lives, galaxies growing and fading, a universe that blooms and fades in what feels to them like a few breaths. They are not trapped, they are simply held. Time for them is slow, soft, careful. And in that care there is a kind of peace. To the outside world they seem to stop, to themselves they live. This is the quiet paradox, that time can move differently depending on where you are, that one moment for you can be a century for someone else. And that black holes are not just objects, they are places where time changes shape. This is what it means when we say time falls asleep. It does not end, it does not vanish. It simply changes its rhythm. It curls into stillness, it slows into quiet, and the black hole becomes the cradle where time goes to rest. Let us now follow time as it slips entirely into rest, past the glow of falling matter, past the stretched light circling the black hole's mouth, past the moment where time still reaches outward. What lies beyond is not just darkness. It is not silence in the ordinary sense. It is stillness at its most complete. Inside the event horizon, time does not flow the way we know it. There is no longer a path forward or backward in any familiar direction. Instead, all roads curve inward, like rivers pouring into one invisible well. Once crossed, the horizon becomes more than a boundary. It becomes a surrender. And yet, there is nothing violent in this image. From the outside, we imagine that anything falling into a black hole is torn or crushed. But this is a story told from afar. From the point of view of the falling thing, be it a particle, a photon, or a person, there is no scream, no jolt, no sudden snap of space. Time carries on, smoothly. One moment follows the next. The change is not a break. It is a deepening, a drift into gravity's fullest form, into a quiet so total that even time cannot escape. In this way, black holes become the final resting places of time's movement. Outside, the universe spins on. Galaxies form and fade, stars burn and collapse, but inside, time ceases to flow in any direction we can name. It may still exist, folded and hidden, like a closed book holding a story that can no longer be read. Or it may end altogether. We do not know. What we do know is that the flow stops. The clock slows not because its gears are broken, but because time itself is no longer something that can be measured. The surface of the event horizon, though invisible, is rich with questions. Some scientists believe it stores information, tiny details about everything that has ever fallen in, not erased, but encrypted, held in the curvature of space itself. This idea, called the holographic principle, suggests that the three-dimensional contents of a black hole might be encoded on its two-dimensional surface. If true, this would mean the edge is not just a border, it is a library, a skin of memory, a surface where time's last messages are pressed like fingerprints into glass. And what happens to these messages? Do they fade? Do they remain forever, hidden but preserved? Or does the black hole itself eventually return them to the universe? Through slow release, through quantum touch, through radiation too faint for us to yet feel, Stephen Hawking believed that black holes may slowly leak energy, a whisper so faint it would take longer than the life of the universe to finish. In that whisper might be the remains of time's softest song. But even without certainty, black holes offer us something beautiful, a reminder that the universe is not simple, that it is layered and curved, full of places where our understanding rests, waiting for more light, waiting for better ears, waiting for a new kind of listening. In that waiting there is meaning. We cannot see what happens past the event horizon. We cannot reach in and pull time back out, but we can learn from what we do see, the slowing of light, the stretching of motion, the quietness of collapse. These things teach us about our own time, how brief it is, how precious. They teach us that even silence can hold depth, that even what disappears may still shape the world it leaves behind. Time falling asleep is not the end of time. It is a change in form, a turning inward, a folding into stillness so perfect that it no longer needs motion to be real. And in that stillness, the black hole waits. It does not act, it does not respond, but it exists with absolute certainty. A place in the universe where everything continues, but differently. We live far from these places, here on Earth, where time flows in steady pulses. But we feel their influence. We watch stars move in ways that betray the hidden presence of these silent centers. We detect the trembling of space from their collisions. We see the dimming of light that falls too close. We listen for the echoes of time as it stretches thin. And though we may never fall into one, the black hole lives in our imagination, as a symbol, as a question, as a boundary to knowledge. It teaches us humility. It shows us that the universe is not designed for easy answers, that some things are meant to remain in mystery, not to frustrate us, but to awaken awe. So if you ever wonder what it means when time falls asleep, think of the black hole not as an end, but as a transformation, a place where time lays down its head, where the rushing of moments becomes the weight of presence, where silence holds the shape of everything that came before. It is not nothing. It is not gone. It is simply resting in the deepest curve of space.